Inside a sealed steel container at 500 degrees Celsius, 3 liquid layers sit perfectly separated. Liquid metal on top, molten salt in the middle, liquid metal on the bottom. Connected to the power grid, and electricity flows out. This is the liquid metal battery, and it may be the most elegant energy storage device ever built. This video is the complete story, the science that makes liquid metal batteries remarkable, the grid storage problem they were designed to solve, and the honest account of why the most promising battery technology of the decade filed for bankruptcy in 2024. Both parts of the story matter. The first thing to understand about liquid metal batteries is why 3 liquids stay separated. Imagine a novelty cocktail. Different liqueurs layered perfectly because they have different densities. That is exactly what happens inside the battery. The layers never mix because physics prevents it. Donald Sadoway at MIT realized something profound about the periodic table. Metals that donate electrons easily, the electropositive ones that work as anodes, are naturally low density. Metals that accept electrons, the electronegative cathodes, are naturally high density. Nature designed the perfect battery. Scientists just had to find it. Here is how it actually works. During discharge, calcium atoms at the top give up electrons. Those electrons flow out as electricity. The calcium ions left behind cross the molten salt to reach the antimony at the bottom, where they alloy together. That is energy being released. Charging reverses the process. The self-heating feature is almost magical. Operating at 500 degrees Celsius keeps the metals liquid. But the chemical reactions during charging and discharging generate heat themselves. Enough heat to maintain the operating temperature without any external energy input. The battery runs its own furnace. Once started, it stays hot. Why do liquid metal batteries last 20 years with almost zero degradation? Because the failure modes of conventional batteries simply do not exist. In lithium-ion batteries, solid electrode particles crack under the stress of expansion and contraction during charge cycles. Liquid electrodes cannot crack. They are already liquid. They absorb the stress by simply flowing. The 20-year lifespan follows from the physics. Every time a liquid metal battery charges and discharges, the calcium dissolves into and redeposits from the antimony alloy. The surface resets perfectly every single cycle. After 10,000 cycles, the electrode looks exactly as it did on day 1. To understand why liquid metal batteries were invented, you need to understand the grid storage problem. Solar and wind generate electricity only when the sun shines and the wind blows. A city runs 24 hours a day. Without storage, every cloud that passes a solar panel is a power outage waiting to happen. MIT researchers calculated what grid storage must cost to make a 100% renewable grid possible. $20 per kilowatt hour. Today, a fully installed utility-scale lithium-ion system costs $100 to $400 per kilowatt hour. That gap, between where batteries are and where they need to be, is the opportunity liquid metal batteries were designed to fill. The liquid metal battery was invented by Donald Sadoway and his student, David Bradwell, at MIT. Sadoway's insight was to think about batteries the way the aluminum smelting industry thinks about molten metals, operating at high temperature with liquid electrodes, using cheap, abundant materials at enormous industrial scale. In 2012, Bradwell and Sadoway published their first liquid metal battery results. Magnesium as the anode, antimony as the cathode, at 700 degrees Celsius. It worked. They then developed the calcium-antimony chemistry at 500 degrees Celsius. Cheaper materials, lower temperature, more practical. In 2010, Sadoway and Bradwell founded Ambry to commercialize liquid metal batteries. Over 14 years, they raised more than $200 million from investors including Bill Gates, India's Reliance Industries, and Paulson & Company. They achieved UL safety certification, ran a pilot with Microsoft, and signed a deployment agreement with XL Energy. The XL Energy pilot in Aurora, Colorado, was Ambry's first utility field deployment. A 300 kilowatt-hour system integrated with solar and wind at the SolarTAC test facility. It tested solar integration, frequency regulation, capacity management, and arbitrage. The battery worked. The technology performed. The challenge was making it economical at scale. In May 2024, Ambry filed for Chapter 11 bankruptcy. The technology worked. The pilots were successful. The demand was real. Customer orders equaled 3 years of planned factory output. The problem was manufacturing economics. The key investor declined to provide $8 million in bridge financing. Ambry could not cover its facility costs. The company was relaunched under the lender consortium, with co-founder David Bradwell as the new CEO. The technology and intellectual property survived. Plans were reaffirmed to ship containerized 1 megawatt-hour systems. But by late 2025, Ambry announced it was winding down after nearly 15 years as a business. 500 degrees Celsius sounds terrifying, but liquid metal batteries have a safety profile that lithium-ion cannot match. No flammable materials, no thermal runaway, no oxygen release. The battery operates hot but cannot catch fire. Puncture a lithium-ion battery and it burns. Puncture a liquid metal battery cell and it simply cools down. Here is the honest verdict. Liquid metal batteries are not dead technology. The science is real. The advantages are genuine. What Ambry proved is that brilliant chemistry is necessary, but not sufficient for commercial success. Manufacturing scale is the hard part. That problem still needs a company willing to solve it. The liquid metal battery concept will be back. The economics are eventually compelling. Abundant materials, no degradation, no separator, self-heating. Other researchers continue the work at MIT and universities worldwide. The question is not whether the technology will find its commercial moment. The question is when, and which company will build it. If this video explained liquid metal batteries in a way that made sense, please subscribe to Future Energy and Technology. We cover every major breakthrough in energy storage every week. Hit like, share it with someone curious about clean energy. Next video, iron air batteries, the rust that could power cities.